today as well.
Oh,
You look like you hated it.
I just don't feel good. So that's my excuse this week. Plus I was talking to Mrs. Dyer. Alright, so we are continuing with the next section, which is mean value theorem and Rolle's theorem. I'm going to get through as much of this today as I can. Maybe if we're lucky, I'll get through the whole section. How would you guys feel if I skipped my proofs today?
That's okay.
Do you just believe me if I tell you something? I don't have to prove it?
I'm always okay with you
Maybe.
skipping it.
You guys are okay?
We'll see. We'll see what
Okay.
it is.
Yeah, if this starts making no sense, I might need a
Alright, if you want to prove, call me out and I'll do it.
Yep.
So, first theorem is Rolle's theorem. The big thing, Rolle's theorem and mean value theorem, they aren't things that we are going to use a ton. But a lot of results in calculus rely on these. So, you know, if you have to at some point take advanced calc, which is basically going back and proving everything in the Calc 1 textbook, like every theorem that I've said, do you want to see the proof? Like that, there's a whole class on that. These are very useful in that situation.
Only if I'm taking
Are you going to
advanced
take Calc 1, 2, and 3 and then advanced calc?
Maybe you should just.
And then advanced, no, I don't think I'm gonna go all the way.
I'll even further.
So, when we do these problems, you are going to have to identify the conditions. Because they're only true if these conditions are met. So the first condition, it has to be continuous on the closed interval. Okay, continuous everywhere, including the endpoints. Second, it has to be differentiable on the open interval. So it's okay if the derivative doesn't exist at the endpoints, but everywhere in the middle it has to. Third condition is f of a is equal to f of b. So what it's saying is if you have a continuous function, so we know continuous means no breaks, right? We are going from a to b, whatever those might be. We know there's no breaks in the graph. If it's differentiable, that means there's no sharp corners or anything that would cause it to be not differentiable. Then there has to be, if the endpoints are equal, so if it starts and stops at the same point, then there has to be somewhere in that interval where the derivative would equal 0. So if these three conditions are true, then there's somewhere, at least one, maybe more than one, place where the derivative is 0. And this is just an example showing you. If it's just horizontal line, everywhere the derivative is 0. Here you would have a point right here where the derivative is 0. This one has a couple. This one has one. So these are just pictures explaining. So
These are all where it stops and ends on the same y axis.
yes, the key is f of a equals f of b. That
Okay.
y values of your endpoints are equal. Then somewhere in between it has to have a derivative at 0. Okay, I'm going to skip to this example. So we're just going to jump a few slides and I'm going to go to example 2 here. I know, just going crazy here. So suppose f of x is x to the 1/2 minus x to the 3/2 on the intervals 0 to 1. Find a number c that satisfies the conclusion of Rolle's theorem. First, we have to make sure we meet the conditions. So what's the first condition?
Closed on, or it's defined.
Continuous on the closed interval, right? We know, if you need to think about this, a 1/2 is the square root. A 3/2 is the square root of x cubed. This is going to be defined as long as x is what kind of number?
A real whole.
Positive number, right? We can take the square root as long as it's positive. So you don't have to give me a lot of explanation here. You just have to state it so I know that you thought about it. So I can just say f of x is continuous on 0 to 1. Okay, you don't really have to tell me why. At this point I'm trusting that. But know that I might give you some that aren't continuous just to make sure you are really in fact thinking about it and not just
So,
assuming.
like this, how do we tell, like just by looking at it, that it's gonna be continuous?
Well, we know like a square root graph looks like this. So it's continuous as long as you're putting in positive numbers so you can evaluate. So basically for the continuous, you're looking for domain errors. Is there anything like dividing by 0, square root of a negative, piecewise functions? Those would be things we're concerned with.
This is like the Spanish Inquisition, like they check to make sure you're still Catholic Christian. This is, you are the Spanish Inquisition.
the second thing, it has to be differentiable. So to check if it's differentiable, let's do the derivative.
1 half x to the negative 1 half minus 3 half x.
So what this means, 1 half x to the negative 1 half, that's like 1 over 2 radical x minus 3 radical x over 2. I'm only writing it like this so I can check. Where would this not exist? If x is 0 or negative, right? So, is it differentiable in the closed interval? No, but it doesn't have to be. Okay, so those are the first two conditions. What's the third condition?
A equals b.
Okay, so f of 0, if I put in 0, square root of 0 minus the square root of 0 cubed.
0.
If we put in a 1, square root of 1 minus the square root of 1 cubed, we get 0, so those are equal. So we've satisfied all the conditions.
What about 4?
Well, there's 3 conditions and then we have our result.
Oh, okay.
So this tells me that Rolle's theorem applies. We met all the requirements. So now we can actually do it, and Rolle's theorem tells us that somewhere between 0 and 1, this derivative is going to equal 0. So I'm going to write it as, with the square roots. You certainly don't have to. If I solve this, I have to multiply that, 6x equals 2. X is 1/3. So my directions were to find a number c that satisfies the conclusion. Is 1/3 between 0 and 1?
Mm-hmm.
Yes, so it is a number between 0 and 1 that makes the derivative 0.
That's crazy.
So what's the theorem itself? Is it just like, this is just verifying that it does apply?
It's saying if these 3 rules are met,
Then
then there is guaranteed to be a number where the derivative is 0.
Why would we need this?
It's a later on.
It
Oh,
is
just wait.
guaranteeing that functions have maxes or mins.
Wait.
I don't know if you were gonna be
Then-
like, and this is how you do taxes, like if there was a real world application.
I mean, maximum and minimum functions are many
You're right.
real world applications.
Whenever it's a straight line,
Every point.
every point is a max and a min.
Because a horizontal line has a slope of 0.
0.
So every single point is, let's see, go to the 0.
That's good.
Alright, here's my function. Does this satisfy Rolle's theorem? So, first, it has to be continuous. Basically, for continuous, we're thinking, do we have domain errors? Fraction exponents, it might help you to write them in terms of radicals, just to think about. Can we do the cube root of anything?
Yeah.
So, it satisfies first condition. You don't have to tell me a lot, you can just say continuous on negative 1 to 1, or you could even tell me it's continuous everywhere, if you wanted. What's the second condition?
Is it differentiable?
Differential. Okay, so let's do the derivative. Derivative of 1 is 0 minus derivative of x to the 2/3 would be 2/3 x to the negative 1/3. That's the same thing as saying negative 2 over 3 cube root of x. Okay, so is this differentiable?
No.
So this is not differentiable at x equals 0. Since 0 is in the interval, we cannot use Rolle's theorem. So I might throw some in where you cannot do it.
I can't wait to be not paying attention and do a whole problem.
Just to find out
That
that
I
you didn't have to.
Yeah,
That's what I'm here for.
I know.
I live for those moments.
I know. It brings you some like sick joy.
Yeah, the whole test is just gonna be
All of you just paying attention, it wouldn't be a best.
Actually, just put your name and turn it in.
One of those read every
Read
question
every
before
question
you begin
before
the
you do it.
test.
And then it's like,
The
look
third
around.
from the bottom
watch
is
the-
going to say, do not take the test.
or else.
Or it's gonna be like at the end of class turning your test.
Alright,
Make a random noise for the
take a
test.
look at this one. Take a second and decide if we can do Rolle's theorem. See if your conditions.
Oh, you wouldn't give us 2 in a row. Look at the original.
Mhm. Oh yeah, we did. Boom, 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 boom.
So if it's a polynomial, you can just say it's continuous and differentiable, because at this point we have theorems telling us that any polynomial is automatically continuous and differentiable everywhere. Third condition, the endpoints have to be equal, so you're putting these into the original. So if I do f of negative 2, negative 8, negative 6,
Mm-hmm.
if you put in 2, you get 8 minus 4 is 2, so negative 6.
Mm-hmm.
So they are the same.
Oh, wait, we put them in their original.
Mhm.
Oh man. That's not cool.
I asked that out loud.
So that
Yeah.
means
I
we
don't pay attention.
can do Rolle's theorem. These are just the criteria. If those are done, then you do Rolle's theorem, which says somewhere the derivative is 0. So we do our derivative equals 0. How would I factor that?
Easy. Or slip and slid.
Slip and slide. Does it work out nicely?
I don't think it does.
No.
Nothing multiplies negative 12 and that's
I'm
negative 2.
just-
So if that doesn't work, what do we do?
Quadratic formula.
Quadratic
Oh
formula.
yeah.
Okay. So the opposite of b. So minus the square root of b squared minus 4ac. Over 2a. So that's 4. We can break 52 up into 4 and 13. I get 1 plus or minus radical 13 over 3. You should do a quick check. It's possible to.
Wait, where did your 2 go?
I divided everything by 2.
Oh, I did. Okay. I simplified and then I tried to.
It's possible that you might get something that isn't in your interval. Like, I could have done the same thing on the interval 0 to 2. And would both of these have been between 0 and 2? No. So you need to check at the end to make sure you're only giving me the values that fall in the interval. But on this one, they both do. So we found 2 of them this time. Alright. Are we okay with what this is telling us?
Yeah. Yep.
Okay.
Yes.
Mean value theorem is like a special or a more generic case. Rolle's theorem is really a special case of mean value. They start off the same. Has to be continuous, has to be differentiable. Rolle's theorem is telling us that somewhere the derivative is 0 if those endpoints are the same. If these endpoints are the same, what's the slope of the line between them? 0. So we're saying somewhere the derivative is 0 and the slope between those is 0. So mean value theorem takes it a step further and says as long as your function is continuous and differentiable, there is somewhere where the derivative is going to equal the slope between the endpoints. Okay, Rolle's theorem is that case if those endpoints are the same, the slope between them is 0, so the derivative is 0. But it could be extended. If I have endpoints and the slope between them is 3, then somewhere the derivative is going to equal 3. Another way to think about it, like if you're driving your car, okay, and your average velocity, so we know velocity is like speed, is 40 miles per hour. Would it be possible for you to have an average speed of 40 miles per hour without ever driving 40 miles per hour?
No.
Yes,
Yes,
if you drive
yeah.
over.
But you would have to hit 40
Yeah.
Oh,
on your
okay,
way to
got
go
it,
over.
Gotcha.
So, somewhere the instantaneous velocity has to equal your average velocity. That's saying somewhere the derivative is equal to the slope between the endpoints. Okay, does that make
That
sense?
made it make more sense.
Good. It's
I-
clicking a little more.
I
now.
needed a
That
thing
makes
that
sense.
like.
Yeah. So the other one, like, would think if you start and stop at the same spot. Okay, you start at school, you're driving your car, and you come back to school. It's essentially saying at some point your velocity would have had to have been 0 if you're going to start and stop at the same point. All right. So there's fewer conditions on this one. This is just a graphical representation. My endpoints can be anything. If I look at the tangent line between them, somewhere the slope of the tangent line on the graph has to be equal. Do I want to do this one? I don't think I'm going to. I'm going to skip this because we're going to fly through this a little bit,
We going straight to
cutting out a few things.
Line a little bit.
Okay, so if I want to find a number where the mean value theorem holds. So it starts out like Rolle's theorem, but it's fewer conditions. It's only the first two. It has to be continuous and differentiable. Is this?
Yes.
Yes, why?
Polynomial.
So you just need to state it. I don't care if you just tell me it's a polynomial, so it's continuous and differentiable. But I do need to see that. And on the test, that's going to be points, just telling me that you thought about those conditions. You know what it is. Then, mean value theorem says somewhere the derivative is equal to the slope between the endpoints. So I need the slope between my endpoints. So if x is 0, if you put 0 into this function, what do you get out?
-1.
0.
Oh wait, into the
Into the function. If x is 2, what do we get out?
yeah, probably.
So the slope between those, y2 minus y1, or x2 minus x1. So my slope is 3. So mean value theorem says somewhere the derivative is going to equal 3. Take my derivative. Equal to 3. Square root is 4/3. How do we get rid of the square?
Square root it.
With that, we always do plus and minus. That would be 2 over the square root of 3.
That's 2 equal 3 over 3.
2 square root 3.
Are both of those in my interval?
Yes.
Wow.
No, the negative half is not.
Right.
Looks
I
like it is.
only wanted the value between 0 and 2. So my answer is just the positive one.
I saw the plus and minus. My brain was like, that doesn't make sense. That was easy.
So does it matter which one you use?
Yes.
My directions were to find a number between 0 and 2.
Yeah, rolls tells you where the point is that it's 0, and then this one is like.
We just found the point where the derivative is 3.
Yeah. Okay.
Alright, let's try another one. So, we are, do I want to do this one? I think I just want to work on straight applications today. Let's just look at this one. That'll probably be my last one. Alright, so I want to decide if I can do the mean value theorem here. So first of all, my function, negative x squared over 3x plus 6. Where is this not defined?
-2.
Okay, so I know x can't be -2. Is that in my interval?
No.
No. So my first condition is met. It is continuous on -1 to 3. Second condition, it has to be differentiable. So we have to do our derivative. So we do our quotient rule. Low, d high, derivative of the top, minus high, d low, derivative of the bottom,
3.
over low, squared.
This was a question on our homework. This was a question on our homework.
Try fixing that. Remember, at this point, we're just trying to decide if this derivative exists. Where does it not exist?
-2.
So that means it is differentiable on -1 to 3. So that means we can do mean value theorem. Rolle's theorem, remember, has 3 conditions. The third one is the endpoints have to be the same. Mean value theorem is just the first 2 conditions. And then we have to prove that somewhere this derivative is equal to the slope between the endpoints. So we need to find the slope between our endpoints. So we are putting these values into our original. If we put in -1, the opposite of -1 squared is -1 over 3 times -1 plus 6. 3, so we get -1/3. If x is equal to 3, 9 over 15. So my slope. y2 minus y1 over x2 minus x1. Over 15 divided by 4.
Can you be positive? There's only 3.
3/5 is small. So I got that my slope is -1 over 15. You guys agree with that? So now what do we do? Derivative equal to -1 over ugly math, isn't it? Okay. So if I cross multiply. Times 15. Is that 180?
Yeah.
Alright, so I'm going to FOIL this out and distribute my negative. So it equals 0.
I think we take 36 out.
Yeah, that'll help. Okay, 36, you could just divide that over and make it go away. Does anything multiply to -1 and add to 2? So what do we do?
Quadratic.
This was a beautiful problem.
You really picked a nice one.
I did. Forgot how awful that was.
Good thing we didn't do number 6. Oh, we're not going back to that because.
That one wasn't too bad, actually.
Well, I'm just writing it.
Oh.
I was expecting to have quadratic form.
Yeah, you should.
You don't remember?
I don't.
It's been a while.
It's been. Every time we do it, I relearn it.
Well,
Do I need to write it down for you?
it's like stuck in.
I know what it is. It's just like
Miss Kelly had it on the wall. and I
that's
just-
yeah. It was on the
Oh
wall.
wait,
So I didn't.
I have a mistake. This isn't 2. That's 4. Why didn't you guys say something?
Because I believed you.
Ah!
We still-
Yeah, we're having faith. Oh, my pen.
Still
Okay.
quadratic formula.
Yeah, it's still quadratic formula, so it's just -4 plus my squared. 4 squared minus 4. Sorry, you guys can just fix 2 numbers and you'll get it.
Isn't the bottom 4?
It's 2a.
Oh, that didn't change.
So 16. That's the square root of 20 over 2. So we finally get -2 plus or minus the square root of 5. That's better. We need to make sure they have to fall between -1 and 3. So use your calculator, check. Do they? And also, I'm missing calculators. Check to see if you had them, please.
I don't have one. Yeah. I finally returned it.
So it's between 2 and 3. So it'll either be
Oh, I didn't put a radical.
The
in there.
negative.
it's negative. Negative will be.
Right, so it's just -2 plus the square root of 5
Yeah.
is the only one in the interval.
I'm glad when I put
Man,
-2 minus radical 5 into my calculator, that got me negative radical 5 minus